Okay, today we're going to be learning about solving compound and absolute value inequalities. We have no common core state standards that focus on this one. This is mainly to build us up so that we're ready to do a common core state standard. Our mathematical practices, though, that we'll be using is the 5. We'll be using appropriate tools strategically. So previously we've solved one-step and multi-step inequalities. Today our objectives are that we will solve compound inequalities and we will solve absolute value inequalities. And our vocabulary is compound inequality, intersection, and union. So looking at this key concept, we're looking at the and of compound inequalities. A compound inequality consists of two inequalities joined by the word and or the word or. So to solve a compound inequality, you must solve each part of the inequality. The graph of a compound inequality containing and is the intersection of the solution sets of the two inequalities. So let's look at what this means. So we've got an inequality, and look, we have compound. There's 2 here. 10 is less than or equal to 3y minus 2, which is less than 19. We were asked to graph the solution set on a number line. So method 1, we're going to solve each of these separately. So we're going to write the compound inequality using the word and, then we'll solve the inequality. So 10 is less than or equal to 3y minus 2, and 3y minus 2 is less than 19. So we're going to solve by adding 2 to both sides. Also here we'll add 2 to both sides. Divide both sides of this equation by 3 and of this equation by 3. So we have 4 is less than or equal to y, and y is less than 7. So we could rewrite it back as a compound. Now method 2 is we can solve both of them together. So we're going to solve both parts at the exact same time by adding 2 to each part and then dividing each part by 3. So adding 2 here, adding 2 here. We're left with 12 is less than or equal to 3y, which is less than 21. Now we're going to divide both of these sides by that 3. So 4 is less than or equal to y is less than 7. So now we're to graph the solution set for each inequality and find their intersection. So first of all, we have y is greater than or equal to, closed circle, 4. And we have y is less than, open circle, 7. You see where these two intersect? So it is, this inequality is greater than or equal to 4, but it's less than 7. So it's the part that falls in between, the part that satisfies both of these number lines. The solution set y such that 4 is less than or equal to y is less than 7. So I do want you to put your answer in set builder notation. Time to check your progress. So pause the video, select your answer, then you can restart the video to find the correct answer. All right, when you solve this equation, you found that x falls in between 3, which is included, and a 6, which is not included. Very good. Now let's talk about the or compound inequalities. The graph of a compound inequality containing or is the union solution sets of the two inequalities. So let's take a look at what that means. We're to solve x plus 3 is less than 2, or negative x is greater than or equal to negative 4. And we're asked to graph the solution set on a number line. So we're going to solve each inequality separately. So x plus 3 is less than 2, or negative x is less than or equal to 4. Here we're going to subtract 3 from both sides and we're going to divide both sides by -1. So x is less than -1, or x is greater than or equal to 4. So here's our -1, and it's an open circle. And then 4 is greater than or equal to, so closed circle. So the union, which means it includes both of these answers, they're going in opposite directions. So that is an OR. The solution set is x such that x is less than -1, or x is greater than or equal to 4. Now it's time for you to check your progress on a compound or inequality. So pause the video. Very good. X is less than -4, or x is greater than or equal to 3. Now we're going to solve absolute value inequalities. So we have 2 is greater than the absolute value of D, and we're asked to graph the solution set on a number line. So 2 being greater than the absolute value of D means that the distance between D and 0 on a number line is less than 2 units. So to make 2 greater than absolute value of D true, you must substitute numbers for D that are fewer than 2 units from 0. In other words, 2 units from 0 could be -2 or +2. So anywhere in between is the absolute value of D. So D is greater than -2 and D is less than 2. All of the numbers between -2 and 2 are less than 2 units from 0. Notice we've got open circles. Doesn't include 2. The solution set is D such that -2 is less than D is less than 2. Now in this instance we have 3 is less than D. Before we had that the absolute value of D was less than. Here 3 is less than. So we're going to graph the solution set on a number line. 3 being less than the absolute value of D means that the distance between D and 0 on a number line is greater than 3 units. To make 3 less than absolute value of D true, you must substitute values for D that are greater than 3 units from 0. So here it looks like an OR, doesn't it? It's greater than 3 units from 0, and it's also less than -3 units from 0. All of the numbers not between -3 and 3 are greater than 3 units from 0. So our solution set reads D such that D is less than -3 or D is greater than 3. Here's the first of our check your progress, so pause the video and work the problem. You can turn it back on when you're ready to check your answer. Very good. X such that x is less than -5 or x is greater than 5. How about this one? Pause the video and work this problem. Very good. X such that -5 is less than x is less than 5. We have another key concept about absolute value inequalities. An absolute value inequality can be solved by rewriting it as a compound inequality. Let's take a look and see what that means. We're going to solve a multi-step absolute value inequality, and then we're going to graph the solution set on a number line. So if we have the absolute value of 2x minus 2 is greater than or equal to 4, that's equivalent to 2x minus 2 is greater than or equal to 4, or 2x minus 2 is less than or equal to -4. So we're going to solve each of these inequalities. We're going to add 2 to both sides, then divide both sides by 2. So the solution set is x such that x is less than or equal to -1, or x is greater than or equal to 3. So we've got closed circles. X is greater than 3, or it's less than and equal to -1. Time to check your progress, so pause the video as you work it. Okay, x such that x is less than -2 or x is greater than 4. Open circle. We don't have an or equal to here. Very good. Now it's time for a real-world example. I want you to pause the video for a little bit as you read the problem, and then come back and we'll get started on solving this. Okay, let's let x equal the actual starting salary. And it can differ from an average by as much as $2,450 a year. So if the salary, and we let x be the actual starting salary, it's less than or could be equal to $2,450. It could differ by that much. So here's our equation. It's our inequality that describes the situation. Now we're asked to solve the inequality to find the range of Hinda's starting salary. So we're going to rewrite the absolute value inequality as a compound inequality and then solve for x. Okay, so we could have it greater than a -2450, or it could be less than a positive 2450. Subtract 38,500 from both sides, and then divide every term by -1. So the solution set is x such that x is, or $3,050 is less than or equal to x is less than or equal to $40,950. So Hinda's starting salary will fall between $36,050 and $40,950. Time for a check your progress, so pause the video as you work the problem. Okay, the absolute value of 7 minus w is less than or equal to 4.5. So that's the inequality that describes this situation. So now we're to solve it. So pause the video as you work it. Very good. The range of weights, so w such that 2.5 is less than or equal to w is less than or equal to 11.5. Excellent job. You are ready to begin the exercises.